Here we are in section 6-2, exercises 1 through 9 and the solutions to those. We're going to be adding and subtracting fractions, so we've got to remember the 3 steps of that. First of all is to get a common denominator, and we do that by making sure we can factor those denominators to see inside of them, to see what they're made of. Once we do that, then we're able to multiply either this fraction or both by something that will give us common denominators. Then we can add or subtract the numerators by keeping that common denominator and then simplify it if possible. So let's go ahead and do that. This guy, go ahead and factor that. That's 2 times 7, and that is 2 times 11. Oh, good thing we factored here. We can see that this guy needs to be times by 11, and that one needs to be times by a 7 on top and bottom. Yeah, there we go. Now on the bottom is simply a 2 times 7 times 11. 2 times 7 times 11. And on the top is 1 times 11 plus 3 times 7 plus 21. So that's going to be 32 over 2 times 7 times 11. That's 77 times 2 is 154. Oh, but wait a second. Can something simplify? Let's leave it in factored form for just a minute. Does 32 allow anything to come out of those? Yes, indeed. 32 divided by 2 is 16. So this is 16 over 77. Oh, good thing we didn't times that up until the very end. Okay, 16 over 77. Number 2. 2 over 15, this is 3 times 5. And 3 over 26, this is 2 times 13. Nothing's common, so the only way to get it common is to times both sides by the same thing. Oh my goodness. Not by the same thing, but by each other. So we have to times by 2 and times by 13, times by 2, times by 13, and times by 3, times by 5, times by 3, times by 5. There we go. Now these two are both 2, 13, 3, 5. That's a pretty big number there. So let's go ahead and multiply the tops. 13 times 2, 26 times 2 is 52, plus, this will all be over 2 times 3 times 5 times 13 on the bottom. 52 plus 3 times 3 plus 5, that's 45. Good deal. So that's 97 over 2 times 3 times 5 times 13. Now, before we times that bottom together, let's see, does that simplify at all? 97, does 97 break down at all? Certainly a 2 doesn't go into it. 3, does 3 go into it? Nope, 5 doesn't, and 13 times 7 is 91, so nope. That looks like the answer. We can write it as 97 over, let's go ahead and times this out. That's 2 times 3 is 6, times 5 is 30. 30 times 13 is 390. All righty. Next one. 4 over 11 plus 3 over 16. Now 16 is 2 times 8, which is 2 times 4, which is 2 times 2. Nothing common here. So the only way we're going to get a common denominator is to multiply the 2 together. So we've got a times by 11 on this side and times by 16. There we go. And do it on top and bottom there. And we're really, if you remember way back, we're timesing by the number 1. This 16 over 16 is just 1, and that 11 over 11 is 1. So we're just renaming the fractions so we can get a common denominator. So this becomes, looks like 64 plus 33 over 16 times 11 is 176. Yeah, so that's 2's and 11 in there. Let me see, 64 plus 33 is 97. Again, is there any 2 or 11 that'll go into that? Nope, 176. Excellent. Okay, next one. Number 4. 2 over x times y. Hey, it's already factored. That's just x times y. 3 over y times z. Common denominator, they both have a y in it, but this guy needs a z, and this guy over here needs an x. So we have 2z plus 3x, not like terms, we can't combine them, over x times y times z. Oh, I guess we don't need to write it with all those dots in there, x, y, z. Excellent. I think that's as far as we can go on there. Wow, sometimes these rational expressions are a little bit easier than the numbers. All right, next one. Number 5. 5 over x squared, which is x times x. Let's remember that. That's x times x there. And then this one is just an x. To get a common denominator, we just need to times this guy by another x there. So we get 5 plus 3x over x times x is now the common denominator, x squared. Good. Number 6. 3 over, let's factor this one, x times x minus 5. And this is, let me see, a y can come out of here. Y parentheses x minus 5. So the common denominator between those two, shoot, what would that be? Oh, they share an x minus 5. That's good. So that's already common. This guy needs a y. Let's put a y there. And this guy needs an x. Put an x there. And so we have 3y plus 6x over xy, x minus 5. Okay, now we have to be careful. This is the first one we run into with the top. We need to see if we can simplify it, which means can we factor the top? So this could be 3y plus 2x. And once you've added them together and you factor that out, you have to double check to see if it'll factor and allow anything on the bottom to cancel. Nope. So that looks like our answer. Good deal. All right, number 7. 5 over x minus 7 plus 2 over x. There's nothing common here, just like the 11 and the 16 up there. So we've got to times this guy by x and times this guy over here by x minus 7. X minus 7. Good, now we have a common denominator, so that is 5x plus 2x minus 14 all over x times x minus 7. Let me see, that's 7x minus 14. And, that looks like that's going to factor just a little bit. Oh, will the 7s cancel? Let's take a 7 out of the top. Let's see if we can simplify it at all. Once we put everything together, not x minus 14, what are you doing? X minus 2 over x times x minus 7. No! So those 7s can't cancel because this 7 is part of this whole factor x minus 7. So you'd have to factor cancel the x minus 7 as a whole thing, and that isn't matched on the top. So here is our answer. Good deal. Number 8. 2 over a plus 3 over b squared. So this is just b times b. So let me see. Yep, nothing in common, so we'd have to times by both b's over here. So times by b squared here. And over here we'd have to times by an a, times by an a. So we get 2b squared plus 3a all over ab squared. Excellent. Yeah, and the top doesn't have anything common, so we can't factor anything out. We're good with that one right there. All right, number 9. 2 over ab plus 3 over b squared. They do share something in common. This one has an ab and this is a bb. So let me see, b times b, and this has an a times b. So if we wanted them to be exactly the same, we'd have to times this guy by another b, and this guy by just an a. So we get 2b plus 3a over ab squared. Almost the exact same thing, but notice the difference in the squared. Since this already had a b, the least common denominator, both of them have ab squared, but this didn't need to change by as much. Good deal. Excellent.